In this video, I'll show you how to solve the ALEKS problem called using a phase diagram to find a phase transition temperature or pressure. So first of all, there are a lot of different iterations of this problem. There are a lot of different options in terms of what ALEKS may be asking you to actually determine or figure out. I'm not going to go through every possible version of this problem, but I absolutely am going to give you enough information that you will be able to answer any one of these ALEKS problems, no matter what it's asking of you. So before we actually get going on this problem, I do want you to take a look at the problem statement at your problem. Some of the problems are going to have you are going to provide you with an initial temperature or temperature information. Not every problem is going to be giving you temperature information. Some of them will be giving you pressure information. But if you have temperature information, it is probably going to be a temperature in units of degrees Celsius. And I want you to notice on the phase diagram that temperature is in units of Kelvin. So the very first thing that you should do if you have a temperature provided to you, right off the bat, convert that temperature into units of Kelvin. The temperature in units of degrees Celsius is just not very useful. So I'm just going to do this conversion real quick. And actually, just to kind of make things simple, I'm going to round my temperature up to 40. So that makes the math really easy. This is approximately 233 Kelvin. Now, if it makes you really uncomfortable that I did that, approximation, fine, you can calculate the exact temperature. That's quite all right. But I do want you to notice that this temperature axis is in increments of 50 Kelvin. So knowing the temperature to the hundredth of a Kelvin is probably not going to be that useful in terms of actually answering this problem. The next thing that I want you to take a look at is, so every one of these problems is going to involve some sort of phase change or phase transition. So I want you to read through your problem and figure out exactly what phase change or phase transition ALEKS is asking you about. Look for a keyword, like in mine, it's asking me about melting. Yours may be asking you about boiling or freezing or something along those lines. So definitely figure out what phase change you're dealing with in your problem and identify the states of matter that are involved in that phase change and the proper direction between those two states of matter. So because my problem is talking about melting, I'm going to be focusing on a solid to liquid transition. If your problem was asking about freezing, you would be focusing on a liquid to solid transition. It's not only important that we recognize the two states of matter that are involved, but also that we recognize the direction that we're moving between those two states of matter. So once you get that figured out, once you know what phase it is that you're dealing with, then you can go to that phase diagram. And what I'm going to recommend that you actually do is just like highlight or pay extra attention to the two states of matter that are involved in your particular scenario. So for me, since I'm dealing with melting, I am not thinking anything about gases at all. Like where I'm working with on the phase diagram is going to be in this area. Okay, so some of the problems are having you start with a temperature like mine. And if you are starting with a temperature like I am, then what I want you to do is find that temperature on the temperature axis. And you're not going to be able to find it exactly like I mentioned because this is in increments of 50 Kelvin, but just get pretty close. And so mine, see, 300 is right. 200 is right here. 300 is here. So this is 250. My temperature of 233 is probably right around here. And what I'm going to suggest that you do visually, because you probably can't do this actually on your computer monitor, is to just draw a line all the way across or all the way up the phase diagram that denotes that particular temperature. Now, if you have been provided with, or if you're working with a problem that is starting you with a pressure, you would do the exact same thing, but you would be drawing it this way. So like maybe my problem, instead of being provided with a temperature, maybe I was provided with 40 atmospheres as my pressure. And so what I would do over here is I'd find that 40 atmosphere point, and then I would just draw a horizontal line all the way across to correspond to that particular pressure. So what I want you to do is find either the temperature or find the pressure that ALEKS is asking you about and just like really make a good visual for yourself. Now, again, what we're going to do is think about what our phase transition is and what direction we're going. And in this phase transition, we are going to be working on this particular line that we drew. So solid to liquid, I'm going to be moving along this vertical line that I drew, and I'm going to be going from the solid area to the liquid area. So for my particular graph, I'm going to pick a different color. I'm going to be going this way on my line. line, on my red line, and I'm going to be crossing that solid to liquid boundary. If you are dealing with a pressure, like if my problem involved 40 atmospheres of pressure, solid to liquid, I would be moving this way on my horizontal line, moving from the solid area into the liquid area. So that's like kind of think about the direction and the location of the phase diagram that you're going to be working with. So this problem is specifically asking me, now I'm ready to actually answer the problem, at what pressure will this particular phase change occur when I'm at this particular temperature? So what the problem is asking is, what's the pressure that corresponds to me crossing from the solid region into the liquid region? And that crossing into the different regions take place right here. That's the point where, if I'm moving along the red line, that's the point where I move from the solid area into the liquid area. And so what I'm doing then is looking for the pressure that corresponds to that particular point. And so if this is 20, this is 5, 10, 15, this is probably about 18 atmospheres. 18 atmospheres. And then notice that ALEKS is giving us a little bit of wiggle room. And so we've got like 2 atmospheres above or below. So that's a total of like 5 atmospheres of range for us to be able to get this pressure correct. So I feel pretty confident that we're going to be able to, even though we rounded and we're estimating off of this axis, we're going to be able to get the pressure pretty correct. So let's think about some of the other ways in which this problem could be phrased, because like I said, there's a lot of different variations of this particular problem. So I'm looking at another ALEKS problem right now, not with this exact phase diagram, but just kind of looking at the scenarios. And it says this one that I'm looking at says find the melting point. I'm just going to abbreviate it MP when the pressure is above 1.8 atmospheres. So again, here's what we're going to do. This particular variation of the problem, I'm not starting with a temperature. I'm starting with a pressure, and it's 1.8 atmospheres. That's not going to work very well on this pressure axis. So let's change that to 18 atmospheres just to make it work better with my data. So since I've been given a pressure to start with, I want to find that pressure on the pressure axis, and I want to draw a horizontal line to kind of denote that pressure. And then I want to think about the phase change, melting. That means that I am going from a solid to a liquid. Same thing as I was before. So again, I'm moving from the solid area into the liquid area along this horizontal line. Along the horizontal line, moving from a solid to a liquid. And that looks like this is the point right here. This is the point where that transition would occur, and so I would just be estimating the temperature in Kelvin at that point. I do think for this particular problem, we're going to get the temperature in Kelvin off of the phase diagram, and then ALEKS is going to ask you to convert it back into degrees Celsius, which is a little bit irritating, but that's what you're just going to have to do. Let me pick out one more. We'll pick out one more scenario so you can kind of see this problem happen one more time. So this last one that I'm looking at, it says the pressure is lowered. It says the pressure is being lowered. The temperature is negative 144 degrees C. And then it's asking what pressure does it need to be for the substance to sublime. It's kind of a tricky one. Okay, so first of all, that temperature, we need that temperature to be in units of Kelvin. So 273 minus 1, let's just change that to 143 to make the math really easy. That's going to be 130 Kelvin. Let's find that temperature. Here's 100, here's 150, so 130 is about at that spot right there. There's our 130. We are subliming, which means that we are going from a solid to a gas. So we're moving along this line right here, and we are moving from the solid state to the gas state. So we're going to be going like that. From the solid state to the gas state. It wants to know what pressure does it take to get that to happen. This is the point on the graph. This is the point where it crosses from solid into gas. So this would be, on this phase diagram, this would be the pressure, which looks like it's about 4 atmospheres. This would be the pressure that corresponds to that phase change. So no matter what, no matter how this question is being phrased, you absolutely have the information to be able to figure this problem out. I totally believe in you. You can do it.